First, Dr. Lucy Green, welcome to the sky at night. But one thing I think I'm going to make straight away, and I don't apologise for saying this often, the sun is dangerous. Whatever you do, don't stare straight ahead, and above all, never look at it through a telescope or binoculars unless you know just what you're doing. If you do that, you're liable to ruin your eyesight. I think it's awfully important. I think you'll agree on that, Lucy.
Definitely, absolutely. The sun is so bright, it doesn't take much to damage your eyes. And in fact, you won't feel it at all because there's no pain sensors in your retina. So the best way is to either look through eclipse glasses or to do a projection of the sun through a pair of binoculars.
Our Earth is 4,500 million years old. The sun is older than that. An ordinary star, nearly 865,000 miles across and 93 million miles away.
That's right. So in fact, when we think about the sun and we think about the structure of the sun, I always like to think of it as an onion. So if we start off at the core in the centre of the sun, this is really the heart of the sun where we have nuclear fusion taking place, which basically converts full protons into a helium nucleus, and it gives off a huge amount of energy, which is then able to trickle through the inside of the sun. First of all, we go through the radiative zone where the heat travels using the process of radiation. In the last third of the interior of the sun, it travels using convection, so huge convective motions happening inside the sun, churning away and transporting the energy up to the surface. And I say the surface of the sun, but actually what I really mean is the visible surface of the sun, or the photosphere. As you go higher in the sun's atmosphere from the photosphere, actually the atmosphere gets hotter rather than cooler. So first of all, you go through the chromosphere where the temperature starts to rise, and then you go through something called the transition region where the temperature rises incredibly steeply, and then eventually your outermost layer of the sun is called the corona, and temperatures in the corona are around a few million degrees.
We know that the sun is gaseous, at least on the surface, but what's it actually made of?
Well, we say that the sun is made of a plasma, and that's something that we call the fourth state of matter. So when material is very cold, it's in the solid state and you can heat it up and it becomes liquid. Heated again, it becomes gas. And if you keep heating it, then eventually that gas is torn apart. So the atoms in the gas are torn apart and it becomes a sea of positive and negatively charged particles. And that's something called a plasma.
And what about these amazing solar flares?
These are some of the most exciting events that we see happening on the sun. Solar flares are indeed the biggest explosions in the solar system, and they follow the solar cycle. So when we have lots and lots of sunspots on the sun, we see lots and lots of solar flares happening. And they're basically a big release of energy in the sun's atmosphere due to the magnetic fields changing and releasing energy. And we see the plasma being heated to millions of degrees.
Why is that?
Well, we think it all lies in the magnetic field. So when we're looking to understand solar flares, we're really looking to see how twisted and distorted the magnetic fields are and looking at how much energy can be stored in the magnetic fields.
Let's talk a bit about sunspots, shall we? Dark patches on the sun's surface, not really dark.
No, that's right. So actually they would shine brighter than the full moon, but because they're set against the really bright photosphere, sunspots appear dark. And really how we need to think about them is in terms of very, very concentrated magnetic fields that poke from deep inside the sun through the photosphere and then up into the atmosphere of the sun.
When you project the sun with a telescope and see the sunspots and do it the next day, you'll find they've moved because the sun is spinning around, taking the spots with it.
The sunspots really were our first clue that the sun rotates, and excitingly actually it showed us that the sun rotates with different speeds at different latitudes. So as you move away from the equator, the surface of the sun appears to rotate slower, which is really curious.
How long does it take the sun to rotate at the equator? About 25 days?
That's right, about 25 days, and then as you move away from the equator it takes longer and longer, maybe up to about 36 days as you're really approaching the poles.
At the present moment, there are not very many sunspot groups on view. We're at the minimum of the solar cycle. Every 11 years the sun's active, then it dies down, and we're now at the trough.
We do see the number of sunspots varying over time. We're not sure exactly why this happens. The dynamo, the generation of the magnetic fields within the sun, is still a really hot topic of debate at the moment and a big area of investigation. But actually, even though we see very few sunspots, the sunspots that we see are very big and quite often very, very active.
We can observe it, and we can use telescopes, but as I said, using the telescope on the sun is dangerous. You've got to know exactly how to do it, and whatever you do, don't look direct. So let's now join Chris Lintel from the garden to show us what can be done.